And I want to get you ready for the quiz that you're going to take here, hopefully right after watching this video on 5.4 to 5.6. So this is going to run through different types of questions that you can use, take notes on this, mark things down so that you can use this to help you on the quiz. So you're going to have to do 2 polynomial long division on this quiz. And when you do the polynomial long division, you want to set up this goes underneath the division bar. This is your dividends. If you have anything missing, so this one doesn't, but if you have anything missing, you have to include your placeholders. And then this is your divisor, so that's going to go outside. So our goal here is to figure out what multiplies to this to get this and kind of work our way through that process. So we have to multiply x by 3x squared to get a 3x cubed. So you're going to put that in the x squared column. You're going to multiply this way. So you're going to kind of think of multiplying diagonally. So 3x squared times x is 3x cubed. 3x squared times 2 is 6x squared. And then you're going to subtract. And when you subtract, I love to use another color. It makes it shows up better. So that will cancel that. So now I have 9x squared minus 6x squared is 3x squared, and then you drop down. And then the process just repeats. So we want to come up with something that multiplies x by to get it to be 3x squared. So that's going to be a 3x, so it goes in my x column. 3x times x is 3x squared. 3x times 2 is 6x. Subtract, so I'm going to change my signs again, use a different color. That will cancel this. 8x minus 6x is 2x. Drop down your 4, and then repeat the process one more time. So we're going to take 2x and divide it by x, or figure out what I multiply x by to get it to be 2x. That's going to be a 2. Multiply, so we multiply 2 times x and 2 times 2. Subtract, so I'm going to change my signs, and this one actually works out perfectly. We get a 0 remainder, so my answer, we call it the quotient, is going to be typed in exactly like this. And if it said, is this a factor of the original polynomial, the answer would be yes, because it did divide evenly with no remainder. You're going to do a lot of synthetic division on this quiz, more than anything else. That's going to be your most common technique. So this next one wants you to use synthetic division to show that x plus 1 is a factor, and then it wants you to factor the rest of it. So we're going to start our polynomial, our synthetic division. So we have 1x cubed, 2x squared, negative 5x, and negative 6. The number that's going outside is what makes this equal to 0. Now that would be negative 1. We know what should happen since it's a factor, so we're going to drop down, multiply, add, multiply, add, multiply, add. This one wants you to go further and write it as a product of factors. So we're going to write down what this means. So this means it's x squared plus x minus 6. We did questions like this that were like volume of a box questions. That will factor. We need numbers that multiply to get negative 6 and add to get 1. That's going to be x plus 3 and x minus 2. And since they want you to write the answer as the product of factors, that is exactly what you would type into Delta Math, and that one is done. Next one just wants you to divide and wants you to write it correctly with the remainder. So this one we don't know if we're going to get a remainder or not. I'm assuming we will just because it mentions it. So we have 2, negative 3, negative 18, and negative 8. And we are going to put a 5 out here because it's what makes the divisor equal to 0. So we drop down, multiply, add, multiply. What is that? 17. Multiply 17 times 5 is 85. Double check my arithmetic. 17 times 5 is 85. Minus 8 is 77. So that's my remainder. So now I want to write it out term by term, including the remainder. So this first number is your x squared. So I have 2x squared. Second number is my x. So I have 7x. Third number is my constant. And then my remainder should be written as 77 over x minus 5. So that's how we write a remainder if we have a remainder, and you will have it both in long division and synthetic division, and that is the way that I expect that you write it. Next one wants you to use synthetic division to evaluate. So this was the remainder theorem. We'll talk about what this means. This is the one where you had to find the remainder, and that gave you the value of the function. So you're going to set up the synthetic division. So 6, negative 1, 4, and 3. And we want to evaluate it at 3, or in other words, find the remainder at 3. So drop down, multiply, add, multiply, add, multiply, that's 165, add. So my answer, my remainder, is 168. And if you want to check that, another way to do it is to plug 3 directly into this polynomial everywhere you see x. You should get the exact same answer. That's what the remainder theorem taught us, is that whatever the remainder is, it's going to be what the function is at that value. Next one, oh, we did a box one like this. I've mentioned it, but we've done a few like this in class. So this is asking you if the volume is x cubed minus 4x squared minus 9x plus 36, and we know the width, it wants us to write the other dimensions. So we're going to start with our synthetic division. So I have 1, -4, -9, and 36. And I know -3, because that's what makes it equal to 0, will end up being perfect. It is a factor. So I'm going to multiply, I'm going to add, multiply, and add. -36. And again, I should get 0 as a remainder. This one wants you to go a step further and factor the result to write the dimensions of the box. So this is x squared minus 7x plus 12. So I need numbers that multiply to get 12 and add to get -7. That's going to be -3 and -4. So the factors that make up the other dimensions of the box are going to be x minus 3 and x minus 4. And that is what you're going to type in as the product of factors of the two dimensions of the box. This was ones that you had to prove that something was a root. These are going to be very quick. You can prove them back to back. You don't even need to start over. So we have 2, -3, -8, and 12. First, I'll prove positive 2. So I'm going to drop down, multiply, add, multiply, add, multiply, add. So I proved that one is a 0. Now I'm going to do the same thing for -2. I do not need to start over. I can just pick up where I left off. So I'm going to drop down, multiply, add, multiply, add. Your proof is getting zeros as your remainders, and that proves it. You can also visually prove this by looking at a graph of the polynomial. Here's ones where I give you one root, you have to find the rest using either synthetic division, factoring, or a little bit of both. So we have 1, 3, -1, -3, and we want to prove that 1 is a solution, is a root. So we're going to drop down, multiply, add, multiply, add, multiply, add. At this point, it is up to you. You can either go to your calculator, look for other roots, or you can see what's left here and see if I can factor it. That actually happens with this one, so I'm going to go do that route, this one, just so you can see it. This factors really nicely. I need numbers that multiply to get 3 and add to get 4. That's going to be 1 and 3, so x plus 1, x plus 3. This is asking you to solve, so this is just not wanting you to write the factors. It wants you to write the other solutions. So -1 and -3 are the other two solutions. Next one's really quick. It's just going to revisit something we talked about midway through this topic. The idea that certain roots come in pairs. We have imaginary roots that come in pairs. We also have radical roots that come in pairs. We call them conjugate pairs. So your conjugate pair will be whatever is there with the opposite sign. So 3 minus 5i is a solution. That means its conjugate pair is 3 plus 5i. If -1 plus the square root of 3 is there, then -1 minus the square root of 3 is there. Again, we call these conjugate pairs. Anything with an I, anything with a square root will always have a partner solution. You always get 2 square root solutions. You always get 2 imaginary solutions. Anything that doesn't have that, so if your answer is just 1/2, that doesn't mean that it has a partner solution. Anything with an I and anything with a square root does. And then the last piece is, can we kind of go all the way through, using your calculator and kind of working from there? So we're going to graph this on our calculator. So we have x to the 4th minus x to the 3rd minus 5x squared minus x minus 6. A lot of minus signs. Make sure you type it in right. Obviously, if you typed in wrong, you're going to be looking at the wrong picture. I'm going to hit graph. So here's what I know, and this is going to help review multiple things in one question. I know that I should have a total number of zeros of 4. So I'm going to kind of make a little note over here. And the reason for that is because the highest exponent is a 4. Anytime you're asked about total zeros, you want to look at all the terms and look for the highest exponent. Your real zeros are going to be visually what you can see on the picture. So in this case, it only crosses through the x-axis twice. So we would say it has 2 reals. Since it has to have 4 total and 2 are real, that means 2 of them have to be imaginary. This answer will always be even. You can have 2 imaginary, you can have 4 imaginary, you can have 0 imaginary. You can't have 1 or 3. You can't have an odd number because they always have a partner. And now the last step is going to be to prove these zeros. So right now it looks like it crosses the x-axis at +3 and at -2. So I'm going to go through and set up my synthetic division. I'm going to start with +3. You can do either one first. Drop down, multiply, add, multiply, add, multiply, add, multiply, add. And again, I just proved that 3 was a solution. Now I'm going to do the same thing for -2. So drop down, multiply, add, multiply, add, multiply, add. That right there proves that my two real solutions are +3 and -2. If you want to know where the imaginary come from, you don't have to find them. What's left, this is an x² + 1, and that will always result into imaginary. So that's where the imaginary come from. It's not something you can see on the picture because imaginary are not x-intercepts, only the real ones are. So that takes you through everything you need to know for 5-4, 5-5, and 5-6. As you take the quiz, feel free to use not only your notes from this, but your notes from everything we've done over the last week, and that should help you be very successful on it.